In class, I showed you how to use the Geogebra geometry tool, just some basic features. I'm going to review everything we did in class so that if you wanted to try to use this tool again, you can remember all of the steps. So the first thing I did after going to geogebra.org/geometry, after going there, I click on the settings in the upper right corner, and I like to see my grid and with the major grid lines, and sometimes I like to show my axes as well. This will be your X and Y axis so that you can plot things. The first thing I did was I showed you how to create a polygon with the basic tools. A few things I want to remind you. When you click on one of the tools, you're locked into that tool until you go back to this arrow that says move. So anytime you want to manipulate something you create, you always have to go back to this move tool. So I'll show you. I'll click on polygon and I'm going to draw the polygon I want. We started with a triangle in class. I'm going to show you today with a square. It's the same idea, or a quadrilateral, I should say. 1, 2, I'm plotting my vertices. And then you're not finished until you close it back up to create the full shape. So I clicked back on my first vertex and that was able to create my shape. So you can see here I have a quadrilateral. It's irregular, it's not a square, all the same side lengths and angles. So once I do that, I can click and manipulate this polygon. But again, I have to go back by clicking on the move tool because if I don't do that, I won't be able to manipulate anything. So what we did was we practiced sort of dragging around the different vertexes and I can reshape my quadrilateral. Now, if you want to create a more specific quadrilateral like a square or a rectangle, we need to know that either for a square, all side lengths are the same, or for a rectangle, that opposite side lengths are the same and that we have all right angles. In order to do that, we need to measure a few things. And on GeoGebra, they make this pretty easy. I'm going to click on More under Tools, and I'm going to scroll down to where it says Measure. I'm going to measure each of my angles first. So if I click on the angle measurement tool, I can either, they give you some tips here, like I can select 3 points or 2 lines to measure one particular angle. So if I wanted to measure angle A here at the vertex where A is, I could either click on the 2 adjacent lines that create angle A, or I can click on the 3 vertices around that create angle A. So I could click DAB. The other thing you can do if you just want to measure all of the interior angles of your polygon, if I just click straight in the middle of that polygon, it does put those measurements on all of my interior angles. And again, I'm going to scroll back up and go to the move button if I want to be able to adjust this. And you can see as I'm moving and manipulating my quadrilateral, those angle sizes are changing according to where I'm dragging them. Sometimes I find it's a little tricky to see those individual angle measurements, so I can click on them and drag them out or a little bit more inside so that they don't get hidden by the angle itself. There we go. So sometimes I just slide them in, which will make it easier for me to see those measurements. I also want to be able to measure my side lengths. So similarly, if I go down to the measure tool, there's the distance or length tool. I can click on that and I can click on each of the lines. So I can click on line AD and it gives me the measure 11.2. I can click on AB, BC, and CD and it will give me the length. And this is in generic units. It's not using like inches or centimeters. So you can make whatever unit you wanted here. Again, if I want to start manipulating that before anyone gets frustrated, scroll back up and click back on that move tool so that you can do that. Again, I like to slide these out a little bit more so I can see them as I manipulate. And you can see what happens as I drag things around, all those numbers update. So if I wanted to make a rectangle, I could really use the grid lines to help me make sure I get those right angles. And I can confirm that it's a rectangle because I can now see that I have 90-degree angles for all of my interior angles. And I can see the side lengths 11 and 11 for my opposite side lengths being equal and 8 and 8. So the grid between the grids and the ability to manipulate this and have the labels, it's really helpful to create specific kinds of polygons. The last thing that I showed you how to do was to create some to create an equation that's going to calculate so you can prove something. So for example, if I wanted to say the sum of the interior angles of this rectangle, I can add up all four of these 90s. So 90 times 4 is 360. But if I wanted to prove that any quadrilateral, no matter how I drag this, right? So if I took and clicked and dragged to make an irregular quadrilateral, if I added up the sum of those angles, it's always going to equal 360 degrees. We did this for a triangle during class, but we could do this for any polygon. If I wanted to prove that, it would be nice to have it automatically calculate that for me and to display the sum here on the screen. So to do that, I'm going to go over to the Algebra tab. And this actually shows you all of our inputs. We clicked it using the tools, but every time you click something in Geogebra, it creates an entry on this Algebra tab. So this is all the things that we did. They're labeling points for us on our polygons. They are labeling segments. So segment AB, right here, sorry, AB, they're calling it, they labeled that as A, so that's the side length. If you want to know, it's really important that you know what Geogebra has labeled each of these. So to do that, actually, let me go back to the tools. I'm going to click on some different parts and display the labels so we know what they called them. So for example, I know I have a label for point A, but I don't have a label for the angle. If I click on the angle itself and then these letters over here, I can show the label and see that they've labeled the angle that's at point A is alpha, that's Greek letter. So it's labeling, I know if I'm selecting alpha in GeoGebra, that's the measurement of this angle right here. So let me actually make sure I add all my labels on so I know what they have labeled them. So angle D, they use delta here. I'm going to show that label. Angle C, they called gamma. And then this angle B, they named that as beta. Okay. Same thing for the side lengths. If I wanted to add up the perimeter of this, I would need to know how they labeled each of these. So I'm going to click on the actual segments, click on the labels and show them. So they called this side length lowercase a. They called this side length lowercase d. It's pretty common in math to be labeling side lengths with traditional alphabet letters and then using the Greek alphabet letters for angles. Okay, so now I have everything labeled. This will help me make my formula. Now that I can see what GeoGebra has called each of these parts, we can write an equation. Now let's go to the Algebra tab. I'll scroll all the way down to the bottom. We're going to add our own new input here. We're going to add an item. So when I click on it, it doesn't give me all of the different formulas, but if I use the word sum, that is one of the programmed formulas that they have in GeoGebra. So if I click on sum, meaning I want to add up the sum of the angles, I'm going to click on the arrow over it and go to where it says sum list. So in other words, I'm going to give them a list of things to add up. All right. One little trick that they don't tell you here, in order to add the list of things, if I want to have it pulled directly from GeoGebra, I need to put squiggly brackets in first. So I just typed the one on the left and it automatically put the ones on the right for me. So now I can start clicking on the things I want it to add up for me. I can click the on-screen keyboard and now I can start selecting which parts I want it to add up. I'm going to switch over the Greek letters because I am adding up angles. And I already said here, it used alpha, beta, gamma, and delta to label them. So I'm going to find alpha, beta, gamma, and delta. So there's alpha. And in GeoGebra, the formula is separated with commas. So alpha, comma, beta, comma, gamma, comma, and then delta. Okay, so these are the lowercase Greek letters. All right, so I wanted to find the sum of alpha, beta, gamma, and delta, and look what it did here. I didn't even have to push anything. I could push enter if I want to get rid of the keyboard or make that full entry, but it has taken the Greek letter epsilon, which is like the equivalent of E, and it said the sum of those angles is 360, and it's claimed epsilon as that value. So I could just leave this here. I'm going to close my on-screen keyboard. And if I go back to my move tool, make sure I'm on that, and then I go back to algebra, and I can see what happens here. As it's adding it all up, I can click and drag this, and you can see those angle values change as I drag this around, right? So I'm dragging it around. Each alpha, beta, gamma, delta will alter as I'm dragging it, but the sum doesn't change. It always ends up being 360. So that's one way of proving it. You can take this one step further. It's not required, but if you wanted to have it show up on the screen itself, I did show you one last tip where you can make a text box appear up here, and it will show you this addition, so you don't have to be in this algebra tab. So I'll show you that. It's not necessary. You can still use it without doing that, but I'll show you how to do it. So one of the things I can do is I can go all the way down to where it says media, and I can add some text. And it asks you to click where you would like that text to show up. So I'm just going to click up here, and I want it to display an equation for me so I can approve. So I can show that all the angles will equal 360. So I can say sum of angles. Maybe that's what I want it to, this is the text I want to display, equals. And then I want to show alpha plus beta plus gamma plus delta. I want to show those live updating, and I want to show what that equals. So the neat thing about this, what I can do is if I go to the advanced, I can actually select directly from GeoGebra what I want it to live display. So sum of angles, all right, I want to show first alpha. So I'm going to click on the GeoGebra tool, and I'm going to find the alpha. When I click it, you'll see it enters it up in my formula with this, with the alpha symbol. When it has this like yellowish orange box around it, that means it's going to pull the live data from what I created on my screen. So I'm going to show sum of angles, alpha plus beta plus gamma plus delta. And I want it to say equals, and then I want it to display the live result for the sum. And if you remember back from our algebra tab, I said pay attention. It called the sum, it named it epsilon. So I'm going to pick that epsilon sign. So basically all of these boxes are like live updates. So when I push OK, you'll see it puts the values that show on my screen here. So sum of angles equals all of those, and the total's 360. Now I'm going to go back up to my move tool. Again, I can't manipulate without clicking on that. As I drag it around, look what happens. It updates live all of those values and shows you. This is proof that no matter how I drag this, I cannot get that sum of interior angles to change to be anything except 360. So this is one way of visually proving that the sum of the interior angles of all quadrilaterals equals 360. You should be able to do the same thing to show this for triangles, for pentagons, for hexagons, and find out what the sum of the interior angles always equals. Of course, there are many other things we can do with the GeoGebra tool. We will use it throughout the unit, but I wanted to make sure that I went over what I introduced during class last week.